Hi, my name is Wei, System and Application Engineer at TI. Today, I'd like to introduce the UCC21520, a 5.7 kV isolated dual-channel gate driver. It is designed to drive different kinds of power transistors, including MOSFETs, IGBTs, and wide bandgap devices, like silicon carbide and gallium nitride with the best-in-class dynamic performance. A simplified block diagram of this driver can be divided into three parts. In the primary side, VCC power supply with under-voltage lockout protection accepts up to 18 volts input, which make it compatible with both analog and digital controllers. Smart protection features like the daytime and disable control also helps to minimize the design efforts. The isolation barrier sits in the middle and has only 1.2 picofarad capacitance with 5.7 kV reinforced isolation. This guarantees common mode transient immunity greater than 100 volts per nanosecond, which is tested through different voltage and temperature corners. The output buffer stage with embedded UVLO protections delivers 4 amps source and 6 amps sink current. Here are test results for the rising and falling time. And 12 volts VDD UCC21520 drives 1.8 nanofarad load capacitance with around 6 nanoseconds rising and falling time and 19 nanoseconds propagation delay. Importantly, the peak current is maintained to be constant and independent with VDD power supply, which helps the designer to predict the driver strength in a variety of load and supply conditions. Here is a close look of the EVM test waveform with on-scope measurement of the propagation delay, rising time, and falling time. The UCC21520 also delivers less than 5 nanoseconds pulse width distortion up to 5 MHz. Furthermore, the propagation delay matching between the two output channels is less than 5 nanoseconds, which means the two output channels can be easily paralleled to double the gate drive strength for some special conditions with large load capacitance. Here is a test of paralleling the two output channels to drive a 30 nanofarad load capacitance. Test setup A drives two 15 nanofarad load, and setup B parallels the output channel and drives the same load. The total power loss is being measured to monitor the internal shoot-through if the propagation delay is not well matched. From the total current consumption, there is negligible difference between these two setups under tri-temperature conditions, from -40 degrees C to 125 degrees C. The last feature introduced here is the daytime. By connecting DT pin to VCCI, the output can be overlapped. Leaving this pin open, set the daytime to be around 8 nanoseconds for interlock protection. Connecting DT pin with a resistor to programming the daytime. With all these advanced features, the UCC21520 enables high efficiency, high power density, and robustness in a wide variety of power applications and topologies, such as synchronous buck and boost, cascaded bucket boost, full bridge configuration, and motor drives. For more information, please visit ti.com, and thanks for watching.